This video is going to serve as an introduction to the class. This class is CSC 1180, Introduction to C++ Programming. So this is a look at the course Canvas page. We're going to be using this a lot. The homework won't be turned in here, but you'll get your assignments. You'll get the reading materials from here. So this course doesn't have an official textbook. There are several textbooks out there. I can list some recommendations on the Canvas page at some point. A lot of those you can find online, lots of sources. I am going to be, this is in quotes, writing a textbook for this course. I'm in the first steps of putting together a textbook. I didn't find what I was looking for in others. So it will be a little less detailed than some of the other textbooks at first, but I will continue to develop those materials. So the materials will be available as PDFs from the Canvas page. So you see at the top here in the general course material, some of the stuff we're covering today. There's an appendix here, so these will be the appendix to the eventual book. The first one's on connecting to the server. Then the second one is on some useful Linux commands, and the third are some useful Emacs commands. So as we'll go over in class, for this class, our programming work will not be done on a PC like you probably did in Python. We won't be using an integrated development environment. Instead, we have a Linux server that's on campus that we can share, and we're going to be using an editor called Emacs to write our programs, and then a compiler called G++, okay, part of the GCC compiler collections. Um, there's a lot of pros to that, I think. It's an experience you probably don't get in other classes. It gives you some hands-on experience with Linux, which is a widely used operating system. Our access will be text-based, which, while not as fully featured as an integrated development environment, it gives you the advantage of being able to really focus in on the code and to focus in on understanding what it is that you're doing. Okay. So in this video, we're going to go through that process of how we connect into the server and how we write our first program, compile it, and all of that stuff. Okay. So we'll probably be going over this on the first Friday of class. So here I am again. You see that the appendices are out there, and this chapter one is out here, which will cover. So I think we actually don't start covering this. I've got it in the wrong week. We're going to start chapter one on the second week of class. So that'll be that second or the first Monday of class, the second week of class. Okay. That's taking a while to pop up for some reason. So anyway, so how you connect into the server will depend on what kind of a computer that you're on. So if you're on a Windows computer, which I assume a lot of you probably are, there's one way to do it for sure, and that's through a program called PuTTY. If you go to putty.org, okay, you can download PuTTY. So you can click on download PuTTY and then go through and find the one that you want here, okay? And you should be able to get this, the installer up here. Should be fine. I assume most of you have a 64-bit computer. If not, a 32-bit would work, okay? So the way that I prefer to do it, so that's if you're on Windows. If you're on a Linux computer, you're probably not, but if so, you can just open up a terminal window. If you're on Linux, I assume you know how to do that because you do that a lot in there. If you're on a Mac, you have the option. If you click on the little bar here, the search button or the magnifying glass, if you type in terminal, it will pop open a terminal window. Which had a bunch of crap on it, but anyway. And then from here, you can connect in. So connecting in to either Linux or to on the Mac through the terminal, or even in PuTTY, the things you'll do here. So SSH is the command used from the command line. The name of the server is Ludwig. Type it correctly. .mcs for math and computer science. .uvaywise.edu. Okay, that's the basic idea. We're going to prepend here to make it a little easier. We're going to put in our username, which is just the first part of your email address, okay, at UVA-wise. So we're going to SSH to our username at the ludwig.mcs.uvaywise.edu, okay? Now, if you're using PuTTY, you'll use this ludwig.mcs.uvaywise.edu. I'm going to put one wise, one W there. You'll put that in and you'll connect on port 22 using SSH, okay? So when you connect to that, this goes in and it knows who you are because you type that in and you type in the password. One thing to note when you're using um, the server is that as you type in characters, it doesn't display them on the screen. So a lot of people freak out and think that it's not, that something's wrong. It's not. It's for security reasons. It's not going to show anything at all on the screen. Okay. So when you see that, no need to worry. Okay. So the way I like to connect if I'm on a Mac, and this is a product that is coming any day now, they say it's out for final testing, onto Windows, is a program called Warp. Okay. And if you go to warp.dev, okay, you can download for whichever system that you're on. Okay. This is a terminal, but it's got a lot of features that you'll see me use in the videos a lot. Okay. It's not required. It is free. And I think as soon as the Windows version comes out, it would be worth exploring. Okay. And then finally, if you're on an iPad, there's a program called Termius, Termius, that you can download, and it should connect as well. The only issue that I've had on using my iPad on the terminal is that I find the keyboard a little bit difficult to maneuver. Okay. So maybe that's just me. Okay. So for this demonstration, we're going to go ahead and connect into Warp. Okay. So when Warp pops up, you get this window here. I'm actually going to share just this screen so you can see it a little bit better. Okay, zoom in a little bit more. Okay. So from here, and I can type in clear to clear stuff out. Okay. Um, Again, this is pretty bare bones. This is going to be the bare bones way that you're going to be experiencing the server for the most part. Okay. And I can type in down here. It's not letting me type in. Okay. Where are we at? There we go. Okay. Yeah, I'm not sure what it's doing here. That's really weird. I'm in some weird mode. See, that's what you get when you try. I'm in annotate mode. You know, you never do these things until you get a video, and then you do. So let's try this again. Okay, okay, up here, normal now. Let me share it again. You will see these videos are not highly professional, and you're going to see this. Okay. One of the things I like about using Warp is that it has this command history built in. Okay, so this is the command I'm going to be doing. So you can type it in yourself. It's not showing the full thing. That's where it, oh, that's in the way. That's the issue. Not sure why that is. Okay. Yeah, the annotation is what's getting in my way. I wonder if I can turn that off. Yes, I moved that. That was the only issue. Okay. So I'm going into the SSH to the to my username at Ludwig all like that. So that's all the same as normal. Okay. Now I'm still in annotate mode. Now I'm not. Now we okay. Now we're okay. Same thing. Type in the password. And again, here you see that it shows nothing, which is what is correct. Okay. So this is a view that you get when you get on to the server. And again, we're getting just command line access, no windows, no buttons, no anything. In fact, your mouse doesn't do you any good at all. Okay. So there's no point in using the mouse. Okay. So most of the stuff here that you see, in fact, I think all the stuff, you don't really have to worry about it. I will say the first time that you connect from a new computer to SSH, it's going to ask you to verify the fingerprint of the server. Just answer yes to that question and it won't ask you that anymore. Okay. So again, most of the stuff we don't care about. Just know that when you see this welcome to Ubuntu 22.04.5, that could change. You're on the server. Okay. And again, typing the word clear gets rid of all that stuff. Okay. So the first time that you log in, you're going to be, you log in with your username, which is again the first part of your email before the ampersand, and the initial password is always going to be QWE123. That's a pretty bad password, but I set that so I don't have to worry about, you don't have to worry about what it's going to be. Okay. So once you've connected in the first time, and again, you don't see much, it just kind of blinks at you. Um, you want to change that password to something that just you know. You do that with the PASSWD command. Commands in Linux are all lowercase. You type it in, you hit enter. It's going to ask for the old password, the QWD123. It's then going to ask for a new password. If it doesn't like your new password, thinks it's too simple to guess, it will give you a warning and give you a chance to change it to something else. Okay. I'm not going to do that because I don't want to change my password. Okay. So that's the first thing that you want to do. The next thing that you want to do is you want to create a directory for this class. If you have me multiple times, you'll create a new directory for each of these classes. Okay. Now, I said before, we're not going to turn in the homework on Canvas, and in general, that's true. Instead, when you create the program on the server, you compile it, you get your executable file, um, then you've turned it in. I'm going to go to your directory, and I'm going to look at your file. I'm going to run it, be able to see your code. I'll be able to grade it from that. Okay, so there's no separate step. If you do the homework in the correct directory, then it's turned in automatically. Okay. I think that that makes it easier for everyone to deal with. So the first thing we need to do, this is a one-time only thing. We're going to make a directory. So we're going to say mkdir, okay, again, all lowercase, space, and it's important that you name this exactly correctly, CSC1180, okay? The reason being, I have a script that I run that's going to go to each of your directories so I can do checking for homework. And if you have named this something different, it's going to mess up my system. So we'll have to make sure that's straight. We're going to do this in class. So this video is more as of a reminder if you need to look at it later, okay? Or if you want to take a look at it in advance. I have not set up the accounts yet. I probably won't until next Wednesday, okay? On the first day of class. But it's important that you get this correct, but if not, we can fix it. There are ways around, okay? So I've done the mkdir. Linux, very terse. It doesn't say anything. It used to be there weren't terminals that would print stuff out in the printer. So in order to save ink, it just doesn't say anything unless there's a problem. Okay. If there would have been a problem, it would have told us. There's not, so we're good. Okay. You can always figure out where you're at in the system by using the pwd command, which stands for present working directory. And you see that I'm in my home directory, which is /home/my username. Okay. If I want to see what's in this directory, we have two options. You can do an ls, okay? You see I've got a bunch of stuff on my server, but in particular, it's this CSC 1180 that we're interested in. You'll have just that, or pretty much just that. We can also do an LL, which is going to give us the long list, okay? So again, I've got lots and lots of stuff. You won't have all that stuff, but you should see that this 1100 directory is here, okay? So to get to this directory, again, I can type a clear if I want. I do the change director command, okay, CD. And you notice in gray there that Warp is trying to figure out what I want to do, okay, but I haven't told it yet, okay. So CSC 1180. So I'm changing directory to that, okay. Again, it doesn't say anything. Note that it does say here that the command line tells us some things here, and it will be different if you're on the terminal program, but the same basic kinds of information. Okay. It tells I'm logged in as me, I'm on Ludwig, and it tells me that I'm in the tilde refers to my home directory. Okay. And I'm in my home directory, that's the /home/your username. I'm in the CSC 1180 directory. Okay. So this is the correct directory for us to be in. Okay. If you're ever not in that directory, CD to it. Okay. If you find yourself lost somewhere on the system somehow, you can do a CD tilde. That's the little thing above the tab key, at least on my keyboard, and that will take you back to your home directory. Okay. And then you can always do a CD CSC 1180 from there. Okay. So again, do an LL here. There's nothing. Okay. The two things that are here, that this shows the parent directory and things like that. We don't care about either of those. There's nothing that we've done here. Okay. So now we're going to go ahead and create our first file. Okay. If you have experience with Linux and know VI, Vim, or some other editor, use it. Doesn't matter to me at all. Okay. There are great arguments and battles raged between which is better, VI or Emacs. To me, they're both fully featured. Pick one, stick with it. If you use one, the other will seem very foreign, but they're both kind of weird. Okay. So I'm going to go ahead and type in the word Emacs, Emacs. Okay. This is A terminal editor's been around a long, long time. Okay. And we next have to type in the name of our program. Okay. We're going to call this one hello.cpp. Okay. So if you're from a Windows background, the whole idea of a file extension means a lot more in Windows. Windows is going to determine what to do with the program based on its file extension. It's not really true on a Linux system, but it does make sense. One of the things we're going to talk about in this class is that there's a tradition in programming, things that we do, that we all do, that we teach the next generation to do, so we don't have to think about it. Okay, so while I could name this file whatever I want, if I name it a .cpp, I'll know what its extension is. I'll know by looking at it that it's a C++ program. Okay, if it were a Python program, I would have named it a .py. Then I would know. Okay, so I'm going to hit that. Okay, you get this. Again, there's not much here. You see that there's some menus at the top, but we're not going to use those. We may use those later, but in general, we're just going to go whole hog into the command line operations, which I found from a whole lot of years of experience is a pretty fast way to do things. Okay. So some things it tells us here, it tells us this is a new file. You see at the bottom, the new file in parentheses. Okay. It gives us the name of the file as hello.cpp. Okay. It's guessing, because of my file extension, that this is a C++ program, which it is. And it tells us that we're on line one, which is also correct. Okay. So we're now going to go through the basic anatomy of a C++ program. We're going to do the infamous Hello World program, and that just shows you that, and there's a reason we do this in any language. Okay. We do it because we want to know what the structure of a minimal program does. And printing's pretty low level. Okay. So we're gonna do this. Okay. Keep in mind that hello world in Python just says print hello world. Okay. Python wants to be your friend. It's a little more forgiving, um, and it protects you from some of the more powerful things you could do. And the reason for C++ still being around after all these years after its invention is that C++ does not sugarcoat things. It gives you full access to the memory, to everything. Okay, so we don't have to, so we can do everything, but we have to be cautious because we can do everything. Okay. So we're going to go ahead and start typing in as normal. The first thing we're going to do, this is going to be on every program that we write, is going to be an include statement for IOStream. Okay. So again, this is all in the first chapter of the book, but we're including here. So the ampersand, that's not an ampersand, it's an octothorpe. So the pound sign, the hash symbol, whatever you want to call it, the tic-tac-toe board, if you prefer, the colors on this sometimes are not super conducive to understanding. That didn't make any better. Okay. Anyway, that shift three is what's called a preprocessor directive, and it simply means that this is not part of the program. It works with the compiler itself, and this is saying go out onto the hard drive somewhere and bring in this system library called IOStream. And the little angle brackets let us know it's a system library, not one that we've created. Okay. And that's where we're going to have the basic input output, which we're going to need for almost all of our programs. Okay. In a similar way, we're going to do something. We're going to set a namespace. We're going to say using namespace standard. Okay. Semicolon. So one of the big changes we're going to see from Python, every line in C++ has a semicolon at the end, unless it's the part of some other thing. So kind of in Python, there was nothing at the end unless it was a structure, in which case it had a colon. What's kind of the reverse. If there's nothing there, then it's a structure. But if it's a regular expression, it's going to have a semicolon. Okay. So that will take a little bit of getting used to. If you don't put the semicolon, it will warn you about it, and it won't compile. It'll be a, a syntax error, and you'll have to fix it. Okay. Um, so that gets the basics out of the way for this program. There could be other things later we'll do with other libraries. Okay. We then go into the main part of this. So we have our main function, okay, which is going to be the keyword int. So again, one of the big differences from Python is that C++ is what we call a strongly typed language. So variables have to be declared as an integer or a double or a float or a string or a char. They can't switch back and forth. Okay, again, more in the book on that. So this int at the beginning of my function says that this function will return an integer when it's called. Okay, that's what the result will be. Okay. It has to be an int. It has to be called main. Um, I didn't teach you guys Python, but often in Python, we get to the point where we're creating a main function to call automatically, but you don't have to. In C++, you have to. If you want this to run from the command line, it has to have a main. Okay. And now we get to the first stylistic differences here. A lot of times, folks, especially in the Java world, want to put the colons there to make the program shorter. And I'm not a fan of that. And do what you want. But the reason I don't do that, I think at this point, our programs are not going to be huge. I like them spread out so we can see what we're doing. Okay. So that begins our main function. I like to go ahead and put in the closing bracket so I won't forget it. Okay. If you have a whole bunch of code, you can always put a comment there to say that this ends main function. If you have a bunch of brackets, sometimes it gets confusing. Okay, but I'm not going to worry about that. We're going for minimal here. Okay. So I will go ahead and take care of this function. It says int main, which means I have an obligation to return an integer. Okay. And in this case, we're not really returning anything that we care about, or that's particularly useful. We're returning a zero, and that's just to say that there wasn't a problem. Okay. If we return to one or something besides a zero, then that would indicate there's some trouble. And we probably won't use that the entire semester, but it needs to be there. Strangely enough, C++ is typically pretty picky about stuff. So it would be, it should create an error if we would compile it without a return, but it didn't used to, at least, because they assume that there's not much use there. Okay. But it's a better habit to put it in there. Okay. So now we just need our one line to output hello world. Okay. So we'd like to be able to say print, but there's no print in C++. Okay. So the way we're going to be printing out for now, and there are multiple ways, we're going to use something called cout. Okay. So cout refers to the standard output device, which for most systems is going to be the screen. Okay. We're then, and the book talks about this more, and we'll talk about it more in class. But the whole idea in C++ is that these input output operations are treated as a stream. That I'm going to set an endpoint, I'm going to send something onto the stream and tell it which direction to move. Okay. For that, we have stream operators. So in this case, we're going to take something, the string that we're going to type in, we're going to put onto the stream heading towards the output. So those arrows are heading toward that. Okay. I put the string here. Only if I find the home keys. Hello world. Okay. And then I'm going to do an endl, which is just a shortcut. It's the same thing as a \n character, which just does a new line feed. That's all it's going to do. Okay. So this is it. This should be our basic program. So let's take a look. Let's compile it. So when you're in Emacs, and again, it's one of I think it's the Appendix C talks about commands. If I do a Control X, a lot of the commands are Control X, Control something else. That means hold down the Control key, hit X. And you see the C-X- appears at the bottom of the screen. Okay, I could do a Control S to save if I want along the way, but if I'm done anyway, I'm going to do a Control X, hold down Control again, hit C. It's going to exit the program. It's going to ask me, do I want to save the file? You've got some options here. If you want to, say yes. If you don't want to, say no. It'll make you like if you make a bunch of changes that were bad. Okay, but I want to say yes. Okay. So now if I do my LL, you'll see that in addition to the nothing I had before, I now have this file called hello.cpp. And this shows us that I have read and write permission to the file, which would make sense. The group, which you see the group's just me, everybody has their own group, has read permission for whatever reason. But the general population, everybody else, the last three here, have no access at all, which is what we want. The D means directories. And again, those are kind of placeholder directories. Okay. So once I have this here, I can now go ahead and compile it. So I'm going to use the G++ command to compile it. Okay. When you use G++, you have to tell it what you want. You don't have to. You should. So let's do it without first. So the simplest way I can do hello.cpp. That's all I need. Okay. The compiler is G++. Hello.cpp is a file that I want to compile. You do that, it tells us nothing. Okay. Which is good. In Linux, it means nothing happened. If I do, or nothing went wrong. If I do an LL, you'll now see that there's a program called a.out. On my screen, it's in green, could be different on yours. Okay. There's a little star there. Stars aren't really part of the name. The reason that it's green and the reason there's a star there is because if you look, there's now an X there, which means it's an executable file. Okay. So I could, if I wanted, and this is just a quirk of Linux. If I just did a.out, it's going to say I can't find anything. Okay. So it doesn't know, it doesn't look in the current directory. If I do a dot slash, you'll notice here there's a dot slash. This dot slash refers to the current directory, and the dot dot refers to the parent directory. So if I do a dot slash a.out, then boom, it runs. There's my hello world. Okay. So that's all there is to that. Again, on most systems, but especially on Warp, if you hit the up arrow, you can go back and not have to type in those commands again. Okay. So I'm back into Emacs looking at my program. Okay. So a couple more things here. So when we're creating our code, if you forget, as you most certainly will, to put a semicolon, if you hit enter, you'll notice it didn't go to the right place. The indentations are off. Okay. And Emacs tries to help you out whenever you forget something and that it's going to do something weird. So you could just backspace over to there, but that's a mistake. When you see that, the odds are something was wrong with the line before. Because now when I hit the return, it lines me right up. Okay. Um, again, spaces do not matter in C++ at all, which is weird. The brackets matter. That's how we define things, and the semicolons at the end. Okay. So that's one thing. The other thing that we should do on all of our programs, okay, that you will get points taken off early on if you don't, is put a comment block. Okay, so two ways to do this. You can do a slash slash and start writing a comment block, and then each line would have its own slash slash as many as you want. Okay, this is like the octothorpe that you did in Python. Or you can do a slash star to start the block. Notice when I did that, everything went in red, okay? Because I've opened up a comment block and I haven't closed it. So right now, the entire program's in a comment block, okay? Then if I do a star slash, it ends that, okay? So the comment is in red, but the rest of my code is now back to normal, okay? So in this comment block for all of our code, we should have at a bare minimum the following, okay? So the program name is hello world, okay? We're going to have somewhere the programmer, and you can just put your name here. Okay. Put that there. You can put the date, not a bad idea. Okay. It's actually 1/7/25 as I'm doing this. Okay. And this will become important later, and it's not always something that you need. It's not required. This is a chance for notes. Okay. So this is I'm going to put our first program, but you don't normally do that. What you would put here is if there are particular techniques um, that you have that may be a little weird, if you're using particular formulas or you're using, weird of any kind of notes that you're putting here. Um, or if there's trouble with the code, if something's not quite working, if this works until you enter a five, then that's where you're going to put this information. Okay. And this is going to be how we're going to let others know or ourselves for that matter. Okay. I don't typically take off a lot for not having comments in your code, but as your code gets more complicated, I really encourage you to make good comments. Okay. So you understand what's going on. If someone else looks at your code later when I'm grading it, it'll be easier for me to understand. If you were doing this for a job, then someone else down the line may get your code and having more comments will help them out. Um, when you see other people's codes, you will be appreciative that they took the time to put comments in. It also, if you look at the code later, even midterm, if you go back and look at the first programs you did, you may forget what you were doing. So it's good to put some comments in. Okay. So this comment block is required. Other comments mostly are not, unless there's an issue. Okay. Although what we'll talk about, I like to use comments as a way to kind of spec out or scaffold my program so I know what I'm going to be doing. And we'll see some of that later on. Okay. So, yeah, I mean, that's pretty much it. So we've got our program, we've got our comment block here, we've got our int main function, we've included the IO stream, we're including using namespace standard. Just so you know, if you don't use namespace standard, your option is to put in std colon colon in front of all of these things. Okay. And that's fine, that works, but I think it's messy and I don't see the point. So we're not going to do it. Okay. So that's kind of it. Let's look at some errors if we want. Okay. So if I don't do that, I'll go ahead and save it. I'm going to compile it again, go up and do it. Okay. It's going to give me the error. Okay. And if you look at these error messages, they're maybe not what you're used to for error messages. They're a lot better than they used to be. It is going to try to tell us what's going on here. Okay. What C++ used to do, it would give us an error on this line 17, and it still is. This is where the error occurs. Oh. So you may be thinking, oh, there's a problem with line 17. There's not. Okay. The problem is detected when it gets to line 17. But it will now show us here that the problem, and it tells us exactly what it is, expected a semicolon before the return, and it puts a little caret there. This is exactly, it thinks a semicolon should go right there. Okay. So that's real straightforward. Okay. Now, warp, other systems won't do this. Warp, if you hit this, for me, the command enter will make that change for me if you want. But I usually do it myself, but whatever you want. Okay. So I go back in. I now know online. Again, I can see down here, I'm on line 14. There's what it tells me. If I go to the end, okay, and Control E goes to the end, or you can just space over. If I do that, then if I go back and compile, now we see life's good. Okay. Oh, I didn't talk about the executable line. We'll do that in a second. Okay. So the other issues that we could have, what if we type that wrong? We leave out the U. Okay. If we run that, compile it, same thing. It'll tell us here that in on line 14, this caught was not declared, which means it doesn't know what it is. Okay. So from that, you're like, oh, it's not caught. You can fix that. Okay. So we go back in and make that C out. So let me show you that when you do this, you will think that you have destroyed the world and it will be really awful. If I put my arrows the wrong way, okay, and try to compile it, you get page after page after page, all kinds of errors that will seem to make no sense. Okay. But what you're looking for here, it will give you that this operator is not found. Okay. So to fix, and again, Warp wants to fix it for me, and it may, but I would rather go back and fix it myself and just realize, yeah, those are going the wrong way. And again, the way I remember it is cout is the screen. So we're sending all these things to the screen. Okay. It's not going from the screen to the string, it's going from the string to the screen. Okay. And that should about do that. That should be okay now, unless I made a typo. So let's go back to our G++ line. So right now we're creating only the program a.out. Okay. And that means if we write another program and compile it, it's also called a.out. So that's not workable, right? So instead, what we're going to do, we're going to be able to name our executable file whatever we want. Okay. In fact, it's a requirement for this class that you have executable files for all of the programs. So I don't have to compile them all. Okay. We do that the G++ like before. Okay. We're going to add, so the hello.cpp is still at the end. That's going to be remain the same. But what we add in between, we're going to add a command line option here, the -o. The -o says, make my executable called something else, and we want to call it hello.exe. There are lots of other things you could call it, but we're going to keep it simple, right? So we all know what's going on. Okay. So if you have a program called hello.cpp, then we're going to make an executable called hello.exe. Okay. If you get these reversed, then you're going to get an error. Okay. The G++ refers to this last thing that you type. If you try to execute the hello.exe, it's not going to exist at this point. Even if it did, you can't try to compile that. Okay. So that's going to be a problem. This part here, all of this is an option. It's an optional parameter. The dash O, the hello.exe goes with the dash O. Okay. This will all seem really foreign at first, but trust me, within a week or two, this is going to become second nature. Okay. So if I do this and compile it, again, it doesn't tell me anything. But now if I do an LL, you'll see that in addition to the hello.cpp, there's now a hello.exe. And again, a dot slash hello.exe will run the program for us. Okay. So I think that's the basics here to get us going. Okay. So on the first week of class, we're going to just go over the basics of C++ and the class structure and all that on Wednesday. No lab this first week, so no lab on Thursday. There normally will be a lab on Thursday. And then on Friday, we're going to get logged in, write our first program, and probably have a real basic assignment to work on. Okay. But the general flow of the class, there'll be a lot of videos, usually before class. You'll have the reading material that I'm creating. You'll also can look it up other places if you want. Okay. Class time, as much as possible, will be spent on going over any problems that you've had with the reading or with the videos. But hopefully the bulk of class time will be on working on programs. That way, I'll be there. Hopefully, we'll have a student assistant there as well to help you work through those problems. So, the homework for this class typically is not doing the programs. The homework is watching the videos and reading so you're ready to do the homework when you're in class. Okay. That will vary somewhat, but that's the basic plan. Okay. So I think I've had none of you before in class, so it's all new. But make sure that if you have questions, I'm pretty reachable. You've got my cell phone number is on the door of my office. It's also on the syllabus. That's not a real cell phone. It's a voice, Google Voice, but does the same thing. You can call, you can text, you can also send me an email. If you call my office number, you may get something. No one ever calls me there, but I would just call my cell instead. Okay. But this is the kind of class that very small changes can make big differences. So if you don't get something small early on, it will keep you from being able to successfully complete your homework. That will just get worse and worse and worse. So if it's not making sense, reach out, ask a question. We'll get it dealt with. It's probably a simple error that you're making. We'll get you on the right track. Okay. You don't want to get behind. Okay. There you can't turn in late programs. I don't give any credit at all for late programs. Okay. The reason being, it's not because I'm a mean, awful person, but the main reason being is that if you get behind, if you don't do this week's work, the next week you have this week's work and next week's work, and it doesn't work out well. Okay. So, I will say though, if you know you're going to be late on an assignment, you've got a ball game, you've got another big assignment, you got a test, you've got a party that your family is making you go to, whatever it is. If you know in advance, or you're just not getting it, if you know in advance before the due date, if you ask for an extension via text or email, then you will always get one extension first time, always, no questions asked. Okay. And then whenever you get it done, then I'll grade it and we'll be fine. If you need multiple extensions, you can ask for them. At some point, I'm going to begin to ask questions about that. Okay. But it's important that we get stuff done. Okay. But always ask questions. Don't be left behind. Stop by my office during office hours. My door may be closed. Knock. If I'm not there, I'm probably wonder. I tend to walk a lot, so I may be walking around somewhere, but that'll be fine. Okay. But stay on top of things. Learn the material well, and the rest will be easy. Okay. So I think that's all I have for this first video. And again, we'll talk about this more in class.